Okay, I just want to go over some of the notes from class. So here's a function, and we're going to talk about the different transformations. We have translation, we have dilations, and we have reflections. So let's start with the translation. So I wrote the function f of x equals sine of x from 0 to 5 pi, and I made some. We can see this the algebraic adjustments I made. So I multiplied the function times a, and then inside I subtracted x by c, then multiplied it by b, and then I added the whole thing to d. So you can kind of guess that the b and the c will affect the x, and the a and the d will affect the y value. So let's start with so I created A and B. A and B I need from 0 to 10 because I don't want positive values. And C and D, C and D are from negative 10 to positive 10. I can have positive or negative values. But so let's start with the C and D. The C is the horizontal shift. This is a translation, and we can see that you have to remember this. It's x minus c. So when c is, it's like 1, 2, 3, 4, 5, it's shifting to the right. Let's move back to 0. When I move c to like negative numbers, so it ends up being like x plus 3, x plus 6. It's like moving the function, shifting the function to the left. We can see that. Okay, let's move back to 0. The next thing I want to do is a vertical shift. And so this is just a plus d. So when I move it, when d becomes positive, it's shifting it up. And when d goes to negative, like function minus 3, function minus 8, it's going negative. One thing, translation, it does not affect the size of the image, which is known as an isometry. Okay, the next thing we want to talk about is the dilations, and that's going to be stretches with respect to specific axis. So the first thing we're going to do is we're going to take this a, like multiplying the whole function by x. So this is a vertical stretch with respect to the x-axis. So we see as a is greater than 1, we see it stretches it's almost like it stretches away. And then as a is less than 1, we see that it kind of like stretches towards the x-axis. But in both cases, we say that it has a vertical stretch with a factor of a. Okay. Now the b, when we're multiplying the x by b, it's a little weird, but you'll get used to it. If a is greater than 1, let's take a look at the purple. What's happening when a is greater than 1? Not the purple, the red. It seems to like shrink, right? So there's a stretch or a shrink with respect to the y-axis. Now let's take a look at what happens when b is less than 1 or greater than 0 but less than 1. It kind of like it really stretches out. So with the horizontal stretch, we say that's a factor of 1 over b. I'll put that in the notes. It seems like the opposite, but no. Okay, let's move back to 1 once again. So if b equals 2, we say there's a horizontal stretch by a factor of a half. But if we move b to a half, like 0.5, we say there's a horizontal stretch by a factor of 2. Okay, let's move this back to 0. Back to 1. Back to 1. Sorry. Okay, now let's take a look at the reflections. So what I'm going to do is I'm going to adjust my sine wave. I'm going to start at pi because I want to move it a little bit, and I'm going to move it up to 3. Good. Oh, let's move that back to 1. Perfect. Okay, so what I'm going to do is my first reflection, if I negate the whole thing, if I do negative f of x, we see that this is a reflection over the x-axis. I mean, if you think about it, all the y values are negated, so it's like it's like throwing a penny into like a reflection pool. It drops to the bottom. Okay. Now, if I negate all the x values, we can see that it's a reflection through the y-axis. It's kind of cool. And then the next thing we can do is actually, this is not, well, it's kind of part of the curriculum. What we can do is switch the x and a y, and we know what happens. This is actually a reflection through the line y equals x, also known as our inverse. Okay, and so what you can do in Desmos, and I asked you to do this, is you can kind of like fool around with that original function. If we bring it back to x, you can actually fool around with, you can fool around with it. What happens if, I move my A, and then move my B, and move my C, and then move my D. You can move it around. You can see how it affects the points. Stretch it out. And that's the idea. So we'll take some notes. Good. Hey guys, so here's the notes for transformations. Just specifically, exactly what is a transformation? What exactly is a transformation? A transformation is of a geometric shape is a function. So it's going to do something to the values. Is a function or mapping that results in a change in the position, shape, or size of the figure. Okay, so in this class, we're just going to be talking about like moving points or functions like graphs over, like shifting up or over. And so the three transformations we're going to be looking at, as you can see in the video, is translations, dilations, and reflection. So a translation is simply a shift. So this is 6a. A translation is simply a shift. So you have to be careful with the first one. So we're going to start off with a function. So if we have f, a function, then if we have x minus, and I use c, this is c to the right, and if you see x plus c, it's c to the left. Okay. Now this is horizontal. And then we can do the same thing with the vertical. So for example, if I have f of y equals f plus d, this is d up. But if I have f of x equal minus d, this is d down. Okay. The next type of transformation we have, this is 6b, and this is a dilation or a stretch. And we know that these are stretches with respect to the x-axis or the y-axis. So if you see, let's take a look at, let's start off with the vertical first. So we can see vertical, if we see y equals like a f of x, we know that it's a vertical stretch, and this is by a factor of A. Okay, and then if it's a horizontal stretch, where we see the x value is affected, that we see this is a factor of 1 over b. So it's a horizontal stretch by a factor of 1 over b, but this is a vertical stretch by a factor of a. A little different, but you'll see it in the video and you'll practice in the exercises. The last transformation we have is in Unit 6C, and these are reflections. And simply put, once again, we're starting off with the y equals. If we have y equals negative f of x, this is like a reflection in the x-axis. And if we have y equals f of negative x, this is like a reflection in the y-axis. And then the last thing is we have x equals y to f of y. If we switch the x and the y, it's like reflecting through the line y equals x. Now, yeah, so these are our 3 transformations. You're going to go through the unit. Just a quick, a fun little exercise that I learned in my other school. The question is, how do we figure out? So the question is, how do we figure out after a transformation where a point goes, right? So I want you to imagine. Here's the fun. So you're going to do the exercise 6A, 6B, 6C. You try to sketch it as best you can. Don't get too, serious about it. I mean, try your best. So the question is, where do points go after specific transformations? So let's see. So imagine there's a function that maps 2 to 9. We don't know what the function is. The question is, after a certain transformation, where does the point go? So let's take up the first case. F of x minus 3. So the question is, what happens to this point after the function is transformed x minus 3? You say, okay, that's easy, Mr. Adler. It's 3 to the right. Well, how do we figure that out algebraically? Well, you can look at this and you say, you know what? You said it was 3 to the right. Therefore, 2, 9 gets mapped to 5, 9. Algebraically, how are we going to do this? Set this equal. X minus 3 equal to 2. Solve for x. And then stick it back in there. So f of 5 minus 3 equals f of 2, which is 9. Therefore, 2, 9 goes to 5, 9. Kind of interesting. Let's try another one. How about, same thing, f of 2 goes to 9. What happens if I shift it 4 to the left and 6 up? Where does 2, 9 end up? Well, you at this point you say, Mr. Adler, this is easy. If you're telling me it's 4 to the left and 6 up, this is going to be negative 2, 15. So by inspection, you know 2, 9 goes to negative 2, 15. Just by looking at that. Let's just do a little algebra. So once again, let's have x plus 4 equal to 2. That means x equals negative 2. I'm going to if I plug my negative 2 in there, I get f of 2, plus 6. So I'm going to, once again, set what's inside of here equal to 2. X equals negative 2. Now, stick f of negative 2 plus 4 plus 6. Well, this is f of 2 plus 6 This is 9 plus 6, which gives us our 15. So that's the algebra. This is the inspection. Cool. Let's move on. Let's do some horizontal shifts. What do you think? So we affected the x, we affected the y just by shift. Now let's do some stretches. How about this? 3f of x minus 5 plus 7. Well, by inspection, some of you are saying, okay, fine, Mr. Adler. You're telling us to take 2 to the right, that's 7, right? And then you're telling us to take the y, multiply it by 3, and then add 7. So what is that? We think this should be 7, 34. Once again, I think that's what's going on. I think this changes my y, 5 to the left, 5 to the right, and I think this 3 multiplies that 9 and adds 7 to it. I think. Let's do the algebra. Fine. X minus 5 equals 2. X equals 7. Okay, I'm plugging it. I got my 7. Let's plug my 7 in here. 3 times f of 7 minus 5 plus 7. 3f of 2 plus 7. Well, I know f of 2 is 9. Nice. 27 plus 7, 34. Excellent. Now, let's do a transformation that kind of confuses me. This is why I'm expecting you guys to move past me and say, Mr. Adler, we got this. I always think this is weird, but, maybe this will help me. So, how about we do negative 6f, open parentheses, 5x minus 1 plus 3. The question is, what's going on here? What's going on here? Well, okay, this is what's happening. We're taking our x value. First, we're moving it to the right by 1. Then, we're stretching it by a factor of 1/5 horizontally. Then, we're vertically stretching it by a factor of 6. Then, we're reflecting it over the x-axis, and then we're shifting it up 3, I think. Yeah. Once again, so x it's 1 to the right. It's 1 to the right, then a horizontal stretch by a factor of 1/5. Then it's a vertical stretch by a factor of 6. Then it's a reflection through the x-axis, and then it's 3 up. Okay, because what we're going to see in the homeworks is that x is then replaced by 5x. The idea is that there was an x value, we moved it 1 to the right, but then we replace x with 5x. Let's look at the algebra. So, let's see. And our so let's see what's going on. So we're going to let 5x minus 1 equal 2, 5x equals 3, x equals 3/5. That makes sense. We took the 1, we took the 2, moved it to the right 1, and then it was a stretch factor of 1/5. For me, my trouble was I didn't understand. I thought I had to factor out the 5, or I just didn't get that. How, I thought, well, it's x times 5 minus 1. No. What's going on here is x is then being translated, and then the x is being replaced. That's what's going on here. It's a little counterintuitive. Maybe for me. Maybe for you guys, you're like, no, we got this, Mr. Adler. That's okay. So, we know that x equals 3/5. Let's replace it up there. negative 6 f 5 times 3 over 5 minus 1 plus 3. We have negative 6 f of 2 plus 3. Negative 6 times 9 plus 3. Stretch this 9 by a factor of 6. Reflect it, so we have negative 54, and then add 3, negative 51. So, based on this transformation, the point 2, 9 is now mapped to 3/5, comma, negative 51. Okay, try the homework assignment 1 through C. I don't think anything like this is difficult, but this just helped me understand specifically this part. Anyway, good luck.